Good morning and welcome to beautiful Mojave, California. We are currently at the Friends of Amateur Rocketry launch site, and we are getting ready for the summer 2025 Georgia Tech Experimental Rocketry launch. So, my name is Michael Pena. I am the outgoing Ramblin Rocket Club president.
My name is Sarah Dea. I am the external structures lead of GTXR.
And yeah, so we're coming to you live today from we're in the middle of the Mojave Desert, and we're getting ready to launch in just a couple of hours. For some context, our launch window actually opened up at 8 a.m. However, we're targeting more of a noon launch for our rocket this year. Some things that are significant about this launch: it's our largest vehicle to date. Live and Let Fly towers up to about 17 feet, and she will serve as a crucial testbed to validate our subsystems for our future and upcoming space shot. Would you like to go into our history of GTXR and how we got to this point?
Yeah, so GTXR started around before quarantine. We started off as a competition rocketry club. We built we've built 6 vehicles so far, starting off with Sustain Alive, Rubber Band Man, Mr. Blue Sky, Fire on High, Strange Magic, and this current one, Live and Let Fly. And we started off as a competition rocketry team, of course, as I said before, and then we started to move towards a more experimental approach where we're not competing against other collegiate teams and we're just doing stuff by ourselves. So we make um, solid motor um, rockets that have 2 stages.
And so, for some context here, Georgia Tech Experimental Rocketry is a project team within the Ramblin Rocket Club. We're one of 2 rocketry teams on campus, and Ramblin Rocket Club is actually home to 5 project teams. And so, GTXR is our largest, and we are mainly focused on experimental flight. So we try to launch every year, and this is now the 6th vehicle. So just um, for review, the design process for the Live and Let Fly vehicle started last year after the end of the Fire on High launch. So, would you like to go into kind of what we experienced there?
Last year we made 2 vehicles. We made Fire on High and Strange Magic. So Fire on High was more of a structural test bed. So we were testing a new fin geometry. We were doing double wedge printed fins, and we decided not to stage. Instead, we had a second rocket called Strange Magic, and that would test our avionics and our custom flight computer. So Fire on High ended in a structural failure, which was the cause caused by roll coupling. So immediately after launch, we started coming up with ideas on how to prevent roll coupling and all sorts of problems that we might have faced. And we started that design cycle probably like in July, and then we continue on until we're here the next year.
Yeah. And in the fall of 2024, we actually began our process by introducing the new and incoming class of freshmen. Every year, we get a bunch of freshmen who are interested in joining not just our organization, but many organizations around campus. And so, kind of how we start them off is just by getting them involved, getting their feet wet, and then going from there, getting them involved with the design process, the analysis process. The fall is really made up of uh, a lot of design meetings, a lot of prototypes and testing, analysis of design, and just iterations so that we can try and perfect, or not perfect, but try and get to meet our requirements for the vehicle that we had set that year. One curious thing to know is how we name our rockets. So that's also done in the fall. Would you like to explain?
Yeah, so we name our rockets after songs in the early or the late 20th century. So we first we sent out a form to all of our members saying like, hey, so usually this is how we name our rockets, and people submit all sorts of names. We have the Macarena, which was a really popular
Yeah.
one. We of course had Live and Let Fly, which is our current one, and we had a couple other ones. Like in the past, we had Material Girl, stuff like that, and we take a vote on which name we want.
Yeah. And it's really just chosen by the members of the team. So everyone gets together. It's a fun night. It's in the middle of the fall, so a lot of the freshmen have already become acclimated to us. And so it's just a great day and opportunity just to, name what the group will be working on for the next about 6, 7 months or so. So that's the fall, and then in the spring we go into way more, engineering processes. Yeah, serious. A lot of our freshmen like to get trained in machine. We have our own machine shop in the AE school, and so we actually get our freshmen involved pretty early. There's a lot of things that we have to go into the shop for, but one of the main things is our propulsion and our motor casings, which is done in on the lathes that we have in the machine shop. You know a lot about the structural work that we do in the machine shop.
So we use a lot of like the CNC mills. We use a lot of the manual mills. We we are most known for using the biggest lathes in the machine shop, and we put our like 8 foot casing, and it's pretty massive. It's very substantial. It's incredibly crazy to see it in real life, but
Yeah, and it's just great because the entirety of our rocket is student designed and manufactured. We do have great sponsors, but really the students are who are the only ones who are touching this design process and the actual manufacturability of the entire design process from start to finish. Um, and then in the spring, as we're getting closer to the summer, we're finalizing a lot of things so that the summer can go off smoothly. So one big thing that you may have noticed is that we go to school in Atlanta, but we're currently in California. Not to mention it's also the summer, so a lot of our students are either interning or doing study abroads. So it's a large process to get all of our students here involved for this weekend and also getting our supplies across the country. So the first thing that happens is this past Sunday, an advance crew actually left Atlanta with a box truck full of our supplies to drive all the way across the country to get here to the desert so that we were able to have everything ready in time for Thursday, which is when the students arrived via air travel or by driving in to actually get ready for the weekend. So do you want to talk a little bit about that process and how far people have flown from?
yeah. So the farthest person that has traveled from the middle of the Middle East, Abu Dhabi, and we've also had 4 students from the Limerick program, and we've had many Europeans besides the Limerick program, like people flying in from London, people flying in from Metz, other study abroad programs, and then we have Convoy, which starts in Atlanta, as Michael was saying, and then we also have people shipping stuff from like different, like when we order things and we have to emergency order stuff. So a lot of stuff was also shipped by Amazon to my house,
Yeah.
which was very fun, I must say.
So yeah, and it all culminates into today, Friday and Saturday, and even Sunday. We currently have around 60 students with us during this launch. Our team is usually hovers around 100 and 120 students every year. So we try and get as many students as we can out here so that even if they've put in any work into the rocket, they actually get to see it launch, and that's a really great value for us. So yeah, students are we fly into LAX and we drive up here on a Friday, so we've actually been working here since 7 a.m. yesterday. Kind of how that process goes, we have multiple shifts. Each shift can vary between 6 and 8 hours. And then during each shift, an essential part or subsystem of the rocket is tested, fitted, and just getting ready for the day today, which is launch, to make sure that everything will work together. And then if anything comes up, we can easily fix the issue within or before the actual launch window. And the reason why Sunday is also a possibility is because our launch window for Saturday is 8 to 5, and our launch window, if we have an additional one on Sunday for 8 to 5, for any variety of reasons, whether we can't launch today, weather, or just something that would happen that we have to launch on Sunday. So that gives us a lot of flexibility to be able to do this. And then all of our students will be back in wherever they flew in from or drove in from by Monday evening, or maybe even a little bit into Tuesday morning. Yeah, depending on how far away they flew. So that just gives you the overall logistics of how we got to this point today. So in a couple of hours, you'll be seeing kind of the overall um, kind of process of getting ready for this launch. So right now, we're coming to you from outside. We're right behind the launch rail. But in the next couple of hours, we will go into a more and more critical state of our rocket prep. So more and more personnel. We'll go into a step called minimum personnel, where only a few essential crew will be out here getting the rocket prepared on our launch pad. You want to explain what the rest of the crew is doing during this time?
Yeah, so while the minimal personnel are taking the rocket down, of course, we're going to have all of our GTXR leads walk the rocket down. It's a tradition that we commonly have, very fun tradition. And then our minimal personnel are just going to make sure that the rocket is aligned. They're going to be checking our avionics system. And then the rest of the crew will be in several of our bunkers. You guys can't see, but we have several bunkers to protect us in case something an anomaly happened. And that's where the rest of the launch crew is going to be, as well as some additional audience members, such as like alumni.
Yeah, and we have many people who actually drive in on the day of launch. So, our crew is around 60 people, but alumni, sponsors, family members will actually drive in for the day of the launch and actually support us here while we're getting ready. So that's just to give you kind of an overview. So far, we've had some critical work being done over the past day or so. We are currently in the final stages, getting stuff ready before we have to go into minimum personnel. But before we go into that, let's talk about the actual vehicle itself, Live and Let Fly. So to give you some quick facts, we're expecting an apogee of around 270,000 feet with an expected Mach of about 4.4. And you might want to go into kind of something unique about this rocket, which is we actually have a set roll frequency for today.
So, as I was saying before, for Fire on High, we suffered roll tickling. So to go against that, we decided to purposely spin our rocket by canting the fins of our sustainer. So we canted them by 1.5 degrees, and that gives us I believe, max roll rate of, I want to say around 20 hertz.
Yeah, like 17 hertz, I think.
Yeah, it was 17 hertz or like, I believe 20 rotations per
Mm.
second.
Yeah. Or somewhere around there.
Yeah, somewhere around there. But that basically it's supposed to prevent us from full coupling or having any other instabilities during flight.
So that's one of the unique things that this rocket you will see. And like Sarah said, that design choice was made due to our rocket last year and the failure that it succumbed to. One of the another things about this rocket is you actually, it's not your standard rocket compared to what you see when you watch like NASA or something. When this rocket ignites and launches off the pad, you may only see it on the pad for about a half a second, up to a second, because this rocket accelerates really quickly. And so kind of how you kind of expecting you for the actual launch, you'll see the rocket take off the pad, and then we'll switch to a camera so you can see it in the air. But to give you some kind of context around this, the main booster, because we have two stages, the main booster will burn out within 11 seconds of the launch. And then after the booster has burnt, we actually separate the two stages, and then the sustainer will ignite and then only burn for about 7 seconds. So the architecture around this is reflecting what we did in the previous year with Fire on High and Strange Magic. Fire on High was an 8-inch booster architecture. It also had a unique recovery system for our booster because that is something we were flying today as well. And Strange Magic was designed around the 6-inch architecture, which is our sustainer, which is generally was used as an avionics test rocket because we were also in the middle of designing our own custom flight computers. So our avionics team is hard at work on getting that up and running so that our future vehicles can actually have our own custom designed and designed PCB boards for our flight computers. So that is kind of what we did. We flew an 8-inch rocket last year and a 6-inch rocket last year, and this year our design is kind of merging the two. So we have an 8-inch booster and a 6-inch sustainer, and you'll see them both soon. They have a really unique center section if you want to go into that.
Yeah, so this year we're doing something called cone staging, and essentially it's a passive staging method in which the stages are attached with the sustainer nozzle is connected to the a aluminum cone that we manufactured, which is attached to the booster. And this aluminum cone was we manufactured that, and it
Yeah.
took us a long time because we essentially started from an 8-inch long, like 2 feet, 2 feet long, 8-inch diameter piece of aluminum stock, and we have to turn it down into a cone all by ourselves. So a lot of machining.
Yeah, so very unique architecture there, a little bit different to the staging systems that we've had in the past. So this is uh, another system that we're hoping to validate for this week. Um, so yeah, I mean that's just a quick summary of Live and Let Fly throughout today in its live stream will, you get to see some interviews from some of the leads and some of the members who worked on this rocket. But for now, if you guys have any questions, you're all welcome to put them into the YouTube comments. Also, I know there are some of you in LA currently watching us, alumni. If you're interested, you can just ask a question to the hosts, and they will get your questions to us. Yeah, we are here, getting ready for all this, so we are happy to answer any questions you guys may have. Just to talk a little bit more about, who we are as a club. Georgia Tech Experimental Rocketry is a sub-project team of Ramblin Rocket Club, but Ramblin Rocket Club isn't just, meant for technical organization and for technical work. We actually focus a lot in a variety of other roles in terms of student organizations. So, there's socializing, which the team does a lot to, because you have to be really well bonded to work really well and efficiently together.
Yeah.
Another thing that we do is we do a lot of outreach, and we actually pride ourselves in the amount of outreach that we do in our local community. So you may have seen us in and around Metro Atlanta, going to local Metro K through 12 schools. We also host a lot of outreach events on campus as well. So for visiting schools, if they are there, we are either tabling or doing presentations, kind of to get them excited about STEM and the world of STEM. And it's a lot that we contribute that we really pride ourselves on that. So if you're interested, if you go to our website, ramblinrocketclub.org, we actually have a section on our outreach if you're interested to read up more about what we do and who we affect in terms of local K through 12 schools. One other thing that we do, we have, like I said, the 4 other project teams. So we're here, we're Georgia Tech Experimental Rocketry, but we're not just, the one project team. So we have a GNC role. So if you want to you want to talk about that a little bit?
GNC stands for Guidance, Navigation, and Control, as you guys know, because we probably took controls. But they essentially also do a, I believe, 1 year design cycle, and this year they launched Vector and Groove, I believe, and they have their own. They also manufacture their own system. They design and manufacture their own control system, and basically create a rocket where they can um, control in the air.
And so GNC is focusing on that. They're one of our most recent organizations. Um, the next one that we had is one that actually started our organization back in 2012, which is High Powered Rocketry. So if you've ever heard of the National Association of Rocketry, they do individual certifications for members in level 1, level 2, level 3 motor certifications. And so Ramblin Rock Club actually helps subsidize that cost for members if they want to come in and get their certification. That's one part of our organization. Another is HAB. So if you've ever seen a weather balloon, we launch high altitude weather balloons to the edge of the atmosphere, and we actually make and manufacture our own payloads to just do our own variety of scientific experiments. One new thing we actually released this past year, which is we're really excited about, is we opened up a high school payload contest. So local K through 12 high schools in Metro Atlanta were actually designing scientific payloads so that we would fly up for them. And so that's just another way that we actually get involved in our community. And then our newest project team is our competition rocketry team. And so they are basically competing in a variety of rocketry competitions around the country. And this past year, they participated in NASA Student Launch, and they actually won an award for their devotion to their outreach because they were actually designing around the high school payload that they were going to fly on their rocket. So just another example of how much outreach that we actually dedicate ourselves to because we are committed to that. But now, one of the questions we're getting is our budget. So how do we, manage to pay for all this? And it's actually, amazing because we actually have a lot of great sponsors. But from the school directly, we get a certain set budget, and then from that budget, we have to distribute amongst our 5 project teams. So what you see here today is actually helped and paid for by the school of Georgia Tech, our student government, our local school, the Daniel Guggenheim School of Aerospace Engineering, one of our major sponsors, the Georgia Space Grant Consortium, and then also a variety of other sponsors that we work with to actually help us get to this point. And it's not cheap. We acknowledge that it's not cheap, but rockets are never cheap. But we are pride ourselves that we are trying to be the most efficient as possible with 5 project teams. Something as simple as standardizing what kind of fasteners we use actually helps reduce the budget a lot in terms of what we spend and what we're actually trying to do. So it's a very big task for us, but it's something that we've been able to manage over the past couple of years in terms of um, you know uh, changing budgets and changing economies and sizing of scale. So yeah.
We also have a shared space. which
Yes.
we share all of our tools, and we're often like helping each other out. Like for example, this year we were helping um, us and GNC were talking a little bit about our fins and stuff like that.
Yeah. Like we have one shared space for all 5 project teams, and every year that we grow, we are looking for more and more space. But we managed to make it work, and we are lucky that we have a great school who works with us to accommodate every time we try and grow. But yeah, it's one room, and we have probably it's probably the size of like a freshman dorm. It is not that big, but
Yeah.
yeah, we successfully managed to actually be organization and space efficient. So yeah, that's that side of the club itself. But to go back into what Georgia Tech Experimental Rocketry as a whole and what we're doing, throughout the year we actually do a variety of testing for different subsystems on our rocket. So one major thing you actually may have seen out there are videos of our static fires. So one thing that we do is when we manufacture new motor hardware, we actually test that first in order to make sure it's ready for flight and it actually can sustain any design changes that we decide to make. So whether that's a new type of propellant formulation, whether that's a new type of architecture, our motor hardware is always static fired first before we actually use it during a launch. And that includes a variety of things, not just um, the static fires themselves, but also just a bunch of different subsystems, like, for example, our igniter system. So this year, our igniter system for the sustainer is using a new kind of architecture for head and ignition. And so that's something that our igniter team has actually been prepping for the entire year. So small changes like that affect our motor hardware every year. And so that's why static firing testing is so needed and actually useful for us in terms of data validation and getting our hardware ready for flight. Um,
One thing I do have to say, because we're super experimental, projects like igniters, where we're creating our own custom igniter instead of buying our old traditional ones, um, it allows us to write papers like AIAA papers, and
yeah,
we end up presenting them at several of our the
Southeast
Southeast
Region 2.
AIAA, yes, Region 2 conference,
Mm.
and we've won several awards in the past year. So,
Yeah. So again, another thing that we do as students is, we write the papers on what we're doing because we actually function on an intent to publish kind of domains. So everything that we do, you're welcome to just look it up. Soon we will put them all on our website, so there you can read all of our papers in terms of what we do. But also, our Instagram is a very good source of what we're actually doing and designing and how our process and thinking goes. Just 2 years ago, when I went for the Region 2 conference, it was actually hosted in the Cape, so it was a very excited time for us. Um, let's see. Oh, you want to talk about any the structural testing you guys had to do?
yeah, or should I talk
Or
about AIAA?
yeah, talk about it. Yeah.
I also went. We both went to AIAA together, and we actually got to tour the Kennedy Space Center, which was also very cool. But we had, I don't remember how many presentations we had, but we had a lot. I believe almost half of the team drove all the way down to the Cape, and we presented our Material Girl, which was our previous rocket before Strange Magic and Fire High. We presented the launch logistics of it. We also presented. I mean, I personally presented a fin testing paper, and it was
Yeah.
oh
Um, yeah.
oh okay. So I presented a fin testing paper, and there's something called fin flutter, which is a structural failure that we sort of analyze, and some things that we're worried about. So we with different fin geometries, it's hard to sort of calculate at what natural frequency your fins are going to flutter off of, and especially because our fins, we use composite sandwich panels, which are essentially a core material and then two faces of carbon fiber, and those are incredibly difficult to analyze and find the natural frequencies of. So my project team and my group basically presented on how we can experimentally find our shear modulus, which was in relation to our natural frequency, and at what speed our fins would flutter. And yeah, that was a very great experience for us.
So now we have some questions coming in from you guys in LA and also on YouTube. So the first question is, what are the goals of launch? And so you want to explain your structural goals?
Yeah, so for our structural goals, we want to sort of validate our roll coupling analysis and our roll coupling, like our dynamic instability models, and to make sure that because we have a designated roll rate, we want to see if we hit that and if our fins will do well for like structurally. And in general, the goal of this launch is to ensure and like validate not only our structural components but our simulations for our space shot in years or whenever the presidents deem it necessary.
And for the other systems on the rocket itself, the motors. So, for example, the 8-inch motor, while we did fly one last year, the one that we're flying this year is a little bit different and we've modified it slightly. So, we're working to see if that's a valid architecture for us going forward. Also, on this rocket was the custom flight computers that we were trying to test for this year. It is a prototype of what we want to do, but we wanted to try and get them tested in time. Some of the stuff that allows us to do, for example, is live stream data from the rocket directly to you guys for the live stream. So we may or may not get that up and running today, but we're going to try and see if that'll work. So avionics is a big thing, trying to get that done. One thing that we've been working on over the past 2 years is trying to um, improve our RF capabilities for the rocket because our airframe is constructed out of carbon fiber. So carbon fiber is notorious for not allowing RF signals to escape. So you want to talk about how we've kind of worked around that?
Um, I'm part of I'm the external structures lead, so I do focus a lot on external structures, which are going to be our airplanes. And this year and last year and the year before, we've been working on sort of external shrouds to hold our GPS and our telemetry antennas on the exterior of the rocket to make sure that they're getting RF transmission, but also being safe from our aerodynamic forces.
So yeah, that's just some of the goals that we had. So one of the next question was, the launch delay. So we can go into this a little bit. So our launch window opened up at 8 a.m., but we decided for the safety of our crew and the rocket itself that we would delay it till noon. This just arose from our testing that we were doing last night, and so we wanted to make a safe and smart decision to just delay the rocket by a couple hours to make sure that when we did launch this rocket, that it was up to all of our specifications and our safety ratings because we do put a lot into safety because this is a big rocket. If it goes wrong, it's really big explosion. So we don't want that to happen. So that's one of the reasons why we pushed back launch to noon. Now, how we are going along with that track, we'll keep you updated on whether or not we'll reach that noon target or go a little bit over. But that's kind of the general reasoning behind why we're delaying our launch from our 8 a.m. launch window to noon. One of the next questions, someone they wanted you to explain more into role coupling, and then another one was the objectives of GNC, the team. So if you want to go a little bit more into role coupling, I don't think they were here for the explanation of why we made the changes we did.
So I can go back from last year where we first initially faced roll coupling because it's never something that we had a problem with on any of our other rockets. It was just last year. And we believe that it might have been because our fins were misaligned with each other because we were trying um, 3D printed fins, which because it makes the process so much easier and you can make multiple fins and it's much cheaper than making our fiberglass fins, which are also a bit of a health hazard because G10 and like fiberglass dust. So we chose to do 3D printed fins for safety reasons. And because of that, some of them were slightly warped and as well they weren't aligned on our rocket. And we believe that was the cause of our roll coupling. So and it basically causes dynamic instability during flight, especially if there's any um, if our angle of attack is different from what we simulate in our sims because of like stuff like wind speeds, angles off the launch rail, stuff like that. So this year we decided to cant our fins because we created a roll coupling model. One of our simulation team members created that, and essentially, if we were to cant our fins on the rocket and create our own roll coupling rate, it's going to give us um, a dynamic instability natural frequency, I believe, where we won't it's very hard to explain right now, but essentially, depending on how much we cant our fins, we're gonna spin at a higher rate, and in that way, we won't um, we won't match our natural frequency of the rocket to therefore roll couple. So that's why we decide to cant our fins by 1.5 degrees.
Yeah. And then one of the next questions was the purpose of the GNC offset. So GNC was started 2 years ago as a passion project between some of our members. So a lot of members in our club wanted to kind of work in the realm of GNC, and so they decided to start their own project team within our organization. And so for the past 3 years now, they've been working on a variety of control techniques for rockets. Their main goal is just try to be able to show that they are able to control rockets. These rockets are smaller than ours because we're large, 17 feet tall, 8-inch wide. They launch rockets more in the realm of like about 3 or 4 feet, and their rockets aren't that wide in diameter. However, they are doing more complex things with their actual control mechanisms. So the first year they began, they were trying to work on canards. Second year, they were working more on thrust vector control. And now the third year, and what they're continuing on to their fourth year, is jet vane technology. And so, like we were talking about earlier with AIAA and their conference, GNC is actually writing a lot of papers on their jet vane technology and their development process. So if you're interested, you can just go into the AIAA Region 2 student conference from this past year for 2025, and you can read a lot on their papers that they were presenting on their jet vane tech. So the current goal for that is to launch a subscale rocket and think in the fall, and then build up a larger rocket to kind of show that they can use jet vane technology to actually control a larger rocket. And those rockets are reaching the limit for launch fields around Atlanta. So soon, if they decide to go any larger, they may have to come out here like we do into the Mojave to launch those types of rockets. Because nowhere around the state of Georgia can you launch anywhere higher than, I believe, 17,000 feet. And today, again, to reiterate, we're launching at 270,000 feet. So we have to go all the way into the middle of nowhere, California, to be able to successfully launch this rocket safely and not, be in the realm of civilization. So, yeah, like for just some context, we drove about 2 hours out of LA from LAX into the desert, and then from our hotel, we drive an additional hour to get further into the desert to then get to here in this point where we can launch safely. Um, so to answer some YouTube comments, so what if the students are worried about the cost of all of our project teams? How can we, what does that look like for them? So to answer that question, plain and simply, RSC charges a due of $20 per semester. That is the only thing we charge. That is the only thing that students have to pay for. Um, so the the dues that we charge are meant for the upkeep of the club itself. So that involves our, various, softwares that we pay for, the safety equipment that we have to purchase, just general upkeep stuff that we do. We put that in the actual dues from, or we pull that from our dues budget. Not only that, this year we started giving out free merchandise, so students have the opportunity to wear free merch from us. But that's the only cost because HPR students can actually get their rockets subsidized up to 100%, depending on the size of the rocket that they're doing. GTXR, like these larger project teams that we have, they pay no cost. Individual students pay no cost, other than this launch here, which is a small cost. But everything else from the flights to transportation is covered. The only thing they pay for is the hotel. Yeah, so we try to make it as simple as possible for students to get involved with us. We try not to make money a barrier. So it's really just more of a dues. But if if a student says they can't pay at all, we don't push. We just say that's fine. Really, we're in here to get experience. We're in here to make friends. We're not here to charge money and get anything. So we try our best. Our treasurers are really talented in being able to balance our budget. So we owe our thanks to them to be able to do stuff like this and do really great things. Um, yes.
Person trying to get my L1 next school.
Yes. Okay, another question. What's the altitude that the parts separate at? I can give you an exact answer in just a bit, but you want to talk about um, the staging. Well, you talked about staging. Yeah, go ahead.
This the project that I was working on personally, but this is the mini swim farm, and it's something that our external structures team was working on. So every year we make, well, last year we started, but we make a miniature model of our fin fan. So this is to sort of test what sort of fins we want to make on our real rocket. So we on this fan On this fin can we have 4 double wedge fins. 2 of them are made out of rigid 10K resin, and 2 of them are still made out of really high. So when we practice and we also onboard our new members on how to make our fins, how to do our heaven super layups on our fins, and also some stuff about our film first. Because we do something called we use pre-fried carbon fibers to do our layups, and we also so every year we also take our real size fin cans, which are around 10 feet sometimes, to Delta Tech Ops, and they allow us to gear our fins and our carbon fiber in their autosave. They're incredibly good. But so my team, we create these fin cans every fall, or I'm going to have them start doing that every fall. And this year, or for this fin can specifically, we wanted to test our alignment. So basically what we did, we aligned the fins using our special alignment tool, and then we took this fin can to LA, and we used one of our sponsors, Hipsidon, to they essentially did a scan of our fin can and compared it with our pad so we could see how aligned our fins were. And this was also to test and test and analyze how we align our fins and to make sure that we don't face roll coupling ever again. And essentially, this project helped us create a better fin alignment tool so that we could ensure correct canting and correct alignment of our fins to prevent roll coupling.
And to answer the previous question about kind of what altitude that we do separation, to give you some quick facts, we actually do our booster burns at around 12,000 feet, and then it coasts an additional 8,000 feet, and around 20,000 feet, and our sustainer will ignite. Now that isn't just a set condition for altitude. There's a lot more that goes into whether the sustainer will ignite or not, to make sure that it ignites in a safe orientation, of one of many other things. But if everything goes well, 20,000 feet is when our sustainer will ignite, and then around 40,000 feet is when our sustainer burns out. And from there on out, it coasts up into our max apogee, which we're expecting around 270,000 feet. As a reminder, our maximum velocity that we're expecting today is around Mach 4.4. So it'll be coasting for about 2 minutes, and then that's when it'll reach its max apogee, and then it'll take a little bit longer to actually descend completely. So 30 minutes, yes. And to go into a little bit about our recoveries today, we actually have 3 segments of our rocket. So we have our booster, we have the sustainer, and then we have our nose cone. The nose cone is what will take the longest to descend, because that's what reaches the top. But they each have their own recovery system, and something unique to this year is our new way of actually deploying our booster parachute, which is a unique and interesting concept if you want to talk about that a little bit.
So okay, we just got an announcement from the far post
Yes.
now. But this year we decided so we have the kebab, which is essentially like all our avionics. And this year, because of roll coupling, we were worried about like several things. We decided to flip it. So normally, I believe we have I'm not super knowledgeable on this, but we usually have our parachutes in the nose cone. And this year we decided to flip it. So instead of having our um, avionics in the sustainer and our parachutes in the nose cone, this time we have our avionics in the nose cone and then parachutes in the
So 3 separate pieces, and they all come down within. Well, the booster is the first to come down. Sustainer takes a little bit longer, and the nose cone's the longest. To go into a little bit about recovery itself, we actually take a lot of great measures to make sure we can recover our rocket. So I'm not exactly sure on the actual spread of how far we go, but basically all around us is just a giant valley. In each direction, there is a salt lake bed. There's more desert. There's more shrubs, and so we have a recovery crew who is especially prepared to go out and recover our rocket. So after we have pointed out where our parts have landed, we are able to leave our bunkers safely, and then we start preparing for recovery. So we have several trained ham radio technicians on our team who will be equipped with ham radios, and then they will be the group leaders for small groups that go out into the desert to actually search for our parts. Now, normally in a nominal situation, when our parts are descending, we're able to point them out, and so we actually have a general direction of where we can walk to. In the event that we don't know where our parts fell, we can use our GPS data to locate kind of the general location where we should start looking. Our recovery crew are equipped with a lot of um, personal protective equipment to make sure that they don't, dehydrate while they're out there or get lost. So, such as things such as high visibility vests and sunshade hats, large water bottles that are equipped with not just water bottles but also first aid equipment. Like I said, we have our ham radio technician in each group so that they can communicate back with us no matter how far away they go. Not only that, we have several cars that can go out into certain access roads so that if a rocket, if a part lands a little bit closer to an access road, we can go directly there, pick it up, and then take the entire crew back in an air-conditioned vehicle, so they don't have to walk all the way back. We also just take several measures to make sure that everyone in the recovery crew is fit and able to go out and actually recover the rocket. And then we take special precautions as well to make sure we leave nothing behind, because everything around us is a nature preserve for California green tortoises, I think. And so we actually make sure that we don't leave any pieces. Even if the rocket crashes, we make sure that we pick up everything piece by piece to make sure we don't leave anything behind. So that goes a little bit about recovery. One of the other questions that we got asked from the alumni was propellant mixture. That is actually our own personal GT Gold formula. It's something we spent a couple years developing. I can't go into exact specifics because we want to keep that to ourselves, but that is something we've been developing for the past couple years. So when I was talking about earlier about our static fires, we actually have our own. We actually had our own static fires meant to test specific propellant formulations, and that was used to generate a general formulation for which is what we're using now, GT Gold, in order to actually be able to do proper models and simulations for that. So,
Yeah, like we test and measure how much thrust each how many grains we put in each water.
one of our alumni asked, "What's the favorite snack of the trip so far?"
Oh, I know. We were just talking about it. We were all
Yeah.
sitting in a circle and talking, and we've had several people mention a large cheese bread, which is apparently $6 at the Cedar Bros. Because I just saw one of our presidents just start eating it, and it was like very large. I thought it was pizza, but apparently we have several people. And oh, Portos is a big one. I bought us a lot of Portos, the potato bowl.
Yeah. I'm in LA, so I got Takis. That's my favorite. It's always gonna be my
Mm.
favorite. That's mine. But yeah, no, out here in the desert though, like that's like hotel food. Out here in the desert, we only drink water. um, Peanut butter jelly sandwiches, high protein food, high caloric food. Because if some of you may or may have not noticed, the high today is about 105, and so we actually take very good precautions to make sure, or we actually take very good steps to make sure that we are keeping all of our members, all 60 of them, hydrated, fed, and properly cooled, because it will get hot throughout the day, and especially if they're working on the rocket outside, we make sure to be able to rotate people in and out so that they're not getting too exposed to the sun and the elements outside. But yeah, that is just a little bit of what we do just here. So yeah. So for now, that's about what we have covered for today. We'll go back online around 11 o'clock to get ready for the launch window, which will open up at 12 for us. That's our own personal set launch window. Um, but if you guys have any questions, you're welcome to leave them on our YouTube comments when we go back online around 11. So we're going to sign off for now. We'll be back and we'll give you a general update on where we are. Currently, the 12 o'clock noon launch window is still what we're running with. If anything changes, when we come back online at 11, we'll make sure we update you on that. Because currently, we're still doing our integrations and getting everything ready to go out to the pad. So, yeah. Want to add anything?
No, I'm excited for a very, very successful launch. Yeah, we have a lot of good hardware on this rocket, and I will be switching out with a different host, but it's very fun.
Mhm.
Sure you guys will enjoy him.
So thank you for tuning in. We'll be back in a couple hours and we'll keep you updated on where we're at with everything going on. Thanks. Hello, and welcome to the GTXR 2025 summer launch. Today, we are getting ready to launch our newest vehicle, Live and Let Fly. Give you guys a general update from kind of what we've been putting out in terms of media on our Instagram. Our launch window opened up at 8 a.m., but for safety reasons, we had to delay our launch window to 12 p.m. So now we are just updating you on where we are at. We are currently expecting to be at or a little bit above our launch window in terms of expected launch time. Currently, the team is in the middle of interacting with the launch rail, and so they're getting ready to get to the next phase of launch preparation. In the meantime, we'll be with you here, giving you some quick example or some quick um, facts about the rocket itself and what we're doing here, and then we will go into a standby phase. So we will periodically come back to you guys with updates on where we're at, and also just some interviews for the team members and some just general information about us, the rocket, and our organization. So today we are talking about Live and Let Fly, which is our sixth vehicle in the history of our organization. So GTXR is a project team for Ramblin Rocket Club. They were started in 2019 with a rocket called Sustain Alive, and then they moved on to Rubber Band Man, Mr. Blue Sky, Material Girl, Fire on High, and Strange Magic. And now we're on Live and Let Fly. So to kind of give you an idea of how we get to those names, you want to explain kind of how we get there?
Yeah. So most of our names are based off of older songs. So Live and Let Fly was based off a song called Live and Let Die. And we go through a voting process early in the year, in the fall semester. And it's a really fun one, actually. It almost always goes till midnight. It was a, it was fun. And that's where we came up with this name, Live and Let Fly.
Yeah.
Yeah.
And Live and Let Fly is our biggest vehicle to date. It is closely reflecting our work from our previous launch last year of Fire on High and also Strange Magic. This year, Live and Let Fly is a towering 17 feet tall. It's a two-stage solid rocket motor. We have an 8-inch booster and a 6-inch sustainer. In total, it's about 260 pounds. And the 260 pounds, and it's expected to go about 270,000 feet expected apogee today. Also, the Mach that we're expecting is around 4.4, so it's also our fastest rocket. Do you want to go into a little bit about the design changes that were made from last year to this year?
Yeah. I can go over some of the major design changes from between our two rockets. One of the biggest decisions that we made was going to a 8.6 rocket, where the top of the rocket, the sustainer, is a different and lighter build than the booster at the bottom, and that should help us go to a higher altitude. Another big design change we made is with some critical components, we started using more advanced machining practices. For example, for the fins, especially for the sustainer fins, which are the most important and that will go through the most of the altitude, those were CNC'd on our school CNC machines by our own structures lead and myself. Yeah. Can they be this visible from now?
Yeah, so Anahad here has machined this out of
Brass. Yeah.
brass. Yeah.
So this is actually a model of the entire Live and Let Fly rocket made out of brass, and we can do a zoom in on this later so you guys can see the actual exact details. But this component here and this component here, both of the fins were all CNC'd, as well as a lot of the internal components, including a lot of our recovery hardware.
Yeah. And so we're going to give you guys some more information about the rocket as the time progresses. Like I said, we're not at our window right now of noon. We actually are expected to go a little bit over that. So we will come back periodically to give you guys updates on where we're at. As you may have been able to tell, we're in the middle of the Mojave Desert. We're at the Friends of Amateur Rocketry launch site, just about 2.5 hours outside of LA. So all of our members flew in this Thursday. We actually had an advanced team that left Atlanta on Sunday to get here in time for this weekend's launch.
Mm-hmm.
The maximum temperature today is a high of 104, and so we are going to take, we're going to take our breaks. We're going to make sure we stay safe. So that's why we're going to be here in periodic segments. But also, once we get closer to the launch, we get down to a stage what we call minimum personnel. So minimum personnel is a stage where personnel, only a limited amount of personnel can be outside and near the rocket or the launch pad. So one thing about the Friends of Amateur Rocketry said that they have are several bunkers that we can use to protect ourselves from anything that may or may not happen. And so when we reach that minimum personnel step, we will go inside and keep giving you guys updates. However, no one other than a few highly trained members will be allowed onto the premises, because they will be doing the final stages of our launch preparation right before and up until that last final that last in a couple final minutes, because the rocket that we're launching today is a big rocket, so it's going to be extremely dangerous if anything were to go wrong, which is why we try to practice safety incredibly well. You want to talk about kind of some of the measures that we're taking right now to keep our 60-person crew out here safe?
Yeah, there are a couple of very, very important measures we've used to keep our crew here safe. Namely, number one is water, water, and water. You like, to get onto site, everyone had to really bring 2-gallon jugs of water, and you're expected to drink water throughout the day. We keep an eye on anyone who is who's under the sun. Like, well, I mean, we're under everyone's eye, right? So we're on the live stream, but anyone who is out and about in the sun has to go with a buddy. I don't think I've seen anyone really go by themselves.
Yeah.
And it's underwatch from everyone for the most part. We drink water. If someone doesn't seem like they're doing okay, even if we want to stay, we bring them back to the hotel. Actually, yesterday I just had to drive someone to the hotel for that reason. So we are very, important. Like, we think it's really important that we enjoy the process of setting up and flying this rocket, and the best way to do that is to stay safe and healthy.
Yeah.
So that's one thing we keep is really important.
Yeah, because anybody can be succumbed to heat stroke, so we make sure we take extreme precaution. Something you guys may be curious about is the fact of our recovery procedures. So today, after launch, our rocket will split it into 3 pieces. In total, the descent time, if everything is nominal, will be about 30 minutes for the last stage, which is our nose cone. So then, when we go to recover our rocket, we actually send out a recovery team of highly trained members to go and recover the rocket and basically mark its location while we can go get vehicles to the site to pick up our rocket. To give you guys some insight on how we take precautions to make sure our members aren't susceptible to the sun and to the heat and to desert, critters and anything else. We have multiple groups that go out. Each group has their own ham certified technician who is responsible for keeping in communication between the recovery crews and mission control back here. Also, each member in the team is given PPE. They're given high-vis vests, and they're also given multiple large water bottles that are insulated so they can keep water with them at all times. And they're also given compasses and other gear to make sure that they'll stay safe while they go out there. So that's just a little bit what we're going to talk about. We'll be back in just a couple of minutes. We'll start playing some interviews for you guys about what our team members are doing. At the moment, as you can see, it is getting a little bit bright with the sun. So we're going to keep just checking in with y'all anytime we get closer and closer to a more definitive launch time. So thank y'all for tuning in. Yeah. Watch them still going. Have lessons as well. Send you a message. Yeah. Should I? When we come. Okay. I was like, why did it take so long? I was about to just. So today is a pretty hot and warm day, right? Did your laptop die? Yeah, my laptop's dead. Oh. Yeah, my laptop immediately died when I got out there. You were out there for 2 minutes and then it was gone. So did we really just wait there for an extra 30 seconds? Feeling. Can you like keep like looking up here every couple of seconds? So I think the message here is like whenever one of us closes our laptop is when you should just like get off. I think my laptop could have made it a little Hello, everyone. Thank you for joining us again here in the Mojave Desert. We are currently at our self-imposed launch window at 12 o'clock. We have 5 hours left in our FAA waiver, but currently we're working to solve an issue that we encountered during integration. So we will actually be back with you around 2:30 p.m. Pacific Standard Time to see where we will be at launch. We are hoping to launch before our launch window ends at 5 p.m. Pacific Time. So stay tuned, and we'll be back at 2:30. Thank you. One, thank you so much for coming back to us here in the Mojave Desert. We have some updates for you all. The launch for today will be scrubbed. We will be continuing with our launch window tomorrow, starting at 8 a.m. We encountered an issue with one of our electrical interfaces on our sustainer, and so we are working through that, are working to fix that today and maybe even through the night, so that we can launch the rocket tomorrow. So we're playing it safe. We're just going to go ahead and not attempt to launch today, and try and use our launch window tomorrow, which opens at 8 a.m. Pacific Daylight Time. So I ask you all that you come back tomorrow and you can go to the same link at our YouTube channel, and we'll be right here to greet you all come morning. So thank you all, and I hope you all have a good night.